Here is a further explanation of unit conversion. Unit conversion is common in physics and science when we have an original expression of some measurement with a given unit. We want that's the same measurement but expressed in different units. So we're not going to change the measurement. We're just going to change the unit that it's expressed in. So let's do an example with really simple numbers where we know the answer so we can focus on the process. For instance, 24 inches, say, is our original expression of a measurement, and we want to change that into feet. You know the answer, how many feet that is, but let's go through the unit conversion process. Unit conversion process says, let's create a conversion factor, which is something I'm going to multiply my original expression by. And I know I want to get rid of inches and end up with feet. I'm going to construct this conversion factor, which is a ratio, so that inches will be down below because that will cancel out the inches outside on the 24-inch expression. It helps perhaps to think of this as 24 inches over 1, like a fraction. Multiplying by another fraction, you realize that you can cancel anything that's in the numerator with anything in the denominator. And I want to end up with feet. So my conversion factor, which is in parentheses here, is a relationship between feet and inches, and it is this relationship, obviously. 1 foot is equal to 12 inches. So when I multiply my 24 inches by this conversion factor, I'm going to get a result. And the inches will cancel out. The inches in the denominator cancel out with the inches in the numerator. And that's all I can cancel out. So now I have to do the fraction math, apply numbers together. And the only unit left is the foot. So 24 times 1 is 24 feet, which is already over there. And then down below, 1 times 12, and that's all that's down below, is 12. So 24 over 12 feet is what 24 inches is equal to. And I think you realize that 24 over 12 is equal to 2. And again, feet are the units that were left over in the math that we did on the left-hand side. So this is the final answer. 24 inches is a length that you know, and that is equal to 2 feet. Same measurement. Measurement is the same, but the units are different. A little further explanation. This was my starting value, and I'm multiplying it by something that, in terms of length, is equal to 1, because 1 foot and 12 inches is the same length. And so you should know that when you have a ratio where the thing on the top is equal to the thing on the bottom, the value of that ratio is 1. So in terms of length, I'm just taking a length measurement, 24 inches, and multiplying it by 1 in terms of length. So I'm not changing the length. I'm being clever here so that the units will change. We are converting the units only to get the 2 feet. You might be asking, why do we do it this way when just doing a proportion would work? The reasons are these two right here. The first one especially. It requires a focus on the units. When you have to think about what you're starting with in the units and think about a relationship between the units you have and the units you want to get, and you can do some simple math to get a new expression, that is better for your thinking and your understanding of the math involved and the physics that's going on. It's a good way to think through these things, especially as you are new to studying physics. Cross multiplying and doing proportions is kind of an automatic, and there's no thought involved, and the units are totally ignored in that case. And this is the way that will deepen your ability to think through problems when there's calculations involved. It also works really well when there's multiple units to convert, and that comes on a little bit later or in future physics courses.